or 23rd chapter of AI. Today we will talk about natural language processing, NLP. For short, there are other abbreviations which use other concepts which use NLP, right? But in terms of AI, we usually use NLP, stands for natural language processing. So anything dealing with natural language. So of course, that's where the major advances have been made. Before we go on to NLP, let's talk. I'll give you a little preview of our final project, right? So you've seen those are the inquisitive, right? You've seen the final group project. We'll do something very similar to this one, right? Except we'll have different headers. Maybe I'll give you more freedom, right? So this is last year's project, right? So in some ways, the API will be easier, right? But it's much more open-ended, right? So you'll have to explore and exploit this world, right? And all this point world, right? And you have to find basically to maximize some values, basically, right? And the catch will be you'll be given a limited number of tries, right? So each of you will have a limited number of tries. It means you can't just keep spamming, millions of queries a second, right? And just exploring everything. So it'll be challenging to find, and the goal is to basically maximize the results, right? So unfortunately, the API from last year, the API doesn't have a server anymore, right? I still have the code from last year, but the code will be slightly different, right? The actual, the secrets, of course, that you'll need to find will be different.
Like the idea
stays very similar, very similar. So you can basically start preparing plenty of ideas. What will change is, of course, the API will be, right? If you check, I'm pretty sure, yeah, it's dead. Right? Yeah.
I run an analysis on it, and it seems that there's also nothing publicly available.
Yeah, it was a Gessner instance, right? And I canceled it a while ago. So, but yeah, so this is actually example APIs, right? You had a whole bunch of them, like 5 of them, I think, right? So here's the thing. Dates will be slightly different, as you looked earlier, but you can do teams of up to 3 persons can do this project, right? So one person can do it, right? But also this means that only one person has to swamp the API, right? So basically, right? So here's an example, right? You have to submit the code, right? Right. You have to submit your exploration, right? So you have to submit the exploration, right? What you use to find, see the space, and then the actual exploitation, the moves, right? Or I call them moves, but in the terms of AI, it's called exploitation, right? So the actual, where you actually do the actual work, basically, right? So you're not allowed to exploit the same area twice. Like you find this amazing coordinates that give you like the highest value, you can't just call it like 10 times, say, okay, yeah, I win, right? No, you have to actually exploit. Let me see again. I think there's one more limitation, especially for this move. Yes. So exploitation, you can use any type of floating point values, right? The actual exploits have to be integers, right? So think about that a little bit, right? So you can do the whole world is this floating point, right? Your map is a floating point, and you can explore that. But the answers, of course, are only integer values, basically. So that's a little bit of extra challenge, right? To make things not so easy, right? So, all right. So basically, to actually get the passing grade, meaning 6 or so, 5, 6, small get. I'll need something that works actually, right? Something that does really work, right? Right? So for one person, right, you'll need to best result out of 3 API addresses, right? 2-person groups, best 2 results, right? And for three-person groups, need to well know three IP addresses. So basically, right. And this is what I did is, I had a few late submissions. If you were running late, you have to do it for 5, right? So, yeah. So it's a trade-off. It's a trade-off, right? Hopefully it gives you an idea. So what will change is I'll change the world, right? Right? So, yeah. Let me see. I see that this is originally this is an honor principle because of course I see your IP address. I mean, you could of course do some sort of access from multiple places, but actually I added I think I'll add the extra step that you have a key basically, meaning you provide a token basically. Everybody will have their own token basically. So that's for the final. So you don't have to worry about spamming too much exploration, right? So again, so what's the point of this whole thing? Of course, it's a way of balancing how much you explore, how much you actually exploit, basically, right? So in a very simple world, right, two-dimensional world, right? The real world is much more complex, right? So, but the API is again keep it very simple, very very simple. So I think in some ways it's easier to get something working than the Gomoku, right? This is a little bit easier. Okay, let's go to our main topic today. Now let's see here. We talk about, of course, NLP. Right. And I just started. Do you have GitHub open? GitHub open somewhere. I kind of swore I got GitHub open. There you go. Right. I have my repositories. Open up. Okay. Let's open the fourth space. So of course, natural language is how we got ahead of all the other species, right? The language, the dolphins, dolphins have some language, right? And I don't know, gorillas, I don't know, they have some language, right? Dogs, they have some communication. Crows, of course, are really smart, right? You've seen crows, right? They know you, actually, like if you go in there, they will remember you if you're mean to them, right? Don't be mean to crows. Right? So, we're one of the smartest animals around, right? As far as birds go, for sure. Right. They even have their own funerals, apparently, crow funerals, apparently. If you want to more. Okay, but let's see. I digress. So, yeah, from caveman, right? We are still around, right? What's happening? This second I so again, is doing some update or something? No. No. Why doesn't it run this? There you go. Okay, yeah, right. So again, it's still defining character, right? So it's of course central to our intelligence, right? So why do we use so for computers? Why do computers need to do natural language processing? Well, it's for communication with humans, right? I mean, we've seen this ChatGPT, right? For learning, right? Again, very important these days, right? Well, of course, for some scientific advancements as well in general, right? So we'll talk about some basic mathematical models that underlie our language. So first of all, what's the difference between a human language and a computer language, right? Programming language like Python or Prolog, right? Or I don't know, Kotlin or Go, right? Well,
how much one is picky against the syntax.
Yeah.
The strict interpretation.
Yes, so it's basically the word which I have trouble pronouncing, ambiguous, right? Ambiguous. So human language is by its nature ambiguous, right? And that's of course what drove early NLP researchers crazy. So okay, write a sentence, and this is in the book actually, right? The notepad. right? That's a book. We can come to more examples, right? Well, there's a lot of example, right? New one, Control N, right? So he saw her dog, right? So, right? So what does it mean? Right? He saw her dog.
He saw her dog. I guess she has a dog.
Yeah, that's one explanation. She has a duck, and he went to her farm and he saw her duck, right? That's one explanation. So what's the other explanation?
Is the duck like bent?
Exactly. He saw her lower the head, right? So there are two meanings at least, right? Speaking of this ambiguity, right? So this is of course a simple example, right? So if you go down to just one letter, like so for example, in English, the most ambiguous word is bow, apparently. There's like 7 meanings or something, right? It's a bow for hair, bowing, there's also for ships, and there's other ways, right? So bow is an extremely ambiguous word. So of course it means the meaning will depend on the context, right? Because if you're talking about ships, it's probably talking about ship's bow or something, right? So this also brings us to one of the big ideas, of course, in NLP, in general, that context is important, where the words are to each other, right? The area, the sort of neighborhood, right? It will sort of define the word's meaning, basically, to some extent, right? So, of course, there's some fixed meanings too, right? So, not much is fixed. Again, of course, famous example, of course, is also, that's bad, right? Popularized by Michael Jackson in the 1980s, right? But it's bad, of course, there's a slang in the 1980s, an old example, 40 years old, right? Saying something is bad in the 80s is actually good, right? Or, of course, cool, of course, another thing. So slang, right? If you go to, what's the name? Urban Dictionary, right? What, so much stuff right there, right? So, lots of different ambiguities, right? So lots of complexity. So we look at something extremely simplest model, right? For language, it's called bag of words model, and it's basically we are going to count our words, or we call them tokens. And you might say, okay, so this will represent our language, or in this case, I'm going to say spoken language. Basically, us basically accounts of tokens, of words. This might seem at the first glance extremely limited model. Yeah, it is limited, right? You look at the better models too, but it also provides some ideas of what can be done. And actually, a lot of progress, a lot of basic stuff can be done with a bag of words model. But before we get to bag of words, so it's basically count, right? So it assumes the words are independent, right? So this means he saw her duck, right? Go to the window, right? But it turns out he can do some classification tasks, like whether it's talking about the movies, or whether it's talking about sports, things like that. He can do pretty well. It might not be able to get this ambiguity too well, but it can still do some things, right? So we can train it, right? Because again, it has the assumption, incorrect assumption, that words are independent, right? They are not. But again, all models are to some extent wrong, right? Just they're useful. So some are useful. But words models can be useful in a simplistic setting, right? Because also we can give it a lot of corpora. It's easy to run. You can be basically anybody with a couple of days of Python knowledge can run it, the basic stuff, right? But there will be some challenges. So first of all, before we actually even make a bug of words model, right? It's basically be counting words, right? So each document will have a count of words, right? That's inside. So first, before we do that, we need to tokenize. So what's tokenization? This is, we are going to break down our text into phrases, words, possibly some other elements, maybe some punctuation, right? This will be a question. Is punctuation its own token? In most modern word models, yes, of course. But I'll start with something simpler, right? So if you're learning basics of artificial AI, right? A sentence, right? So this splitter, it's a tokenizer. It's very limited because why? It will as you can see here, note, the dot after it is after the a better tokenization tokenization would have the punctuation. Yes. Yeah, we can use regular expressions and all the tools. We can, for now, just demonstrate, right? So you can see this example, right? We have a list, we have an array, right? We have a sequence of words, right? And we can say, okay, these are tokens. These are our smallest building blocks for now, right? So there are actually other languages who have problems with this, of course, right? Again, so punctuation it doesn't handle, right? We have some other problems. For example, V, right? What's the problem with V? It's capitalized. Royal V, I guess. It's called Royal V, right? But no, we want it lowercase probably. Why? Why do we want lowercase? Because it's probably the same thing as a regular W, right? WV or WE. Meaning the reason it's capitalized because it's at the beginning of sentence. And for the simple bag of words model, we don't care if it's at the beginning of a sentence. We just want the word be. And of course, we can also argue I don't know if you mentioned stop words, right? There's also issue of stop words. You want to talk about stop words? I think I'll talk about a little bit, right? Yeah. So punctuation, removing stop words. So all kinds of analysis are maybe hampered or meaning delayed or doesn't work very well if you have these words which don't have real like a kind of that are kind of very common, like we, of, like these very frequent words, right? For analyzing sentence structure, they're important, but for actual meaning, well, yes, there might be ambiguities, but for many basic tasks, you don't really need these stop words. So it's very common in NLP tasks to get rid of these stop words. Again, why? Because they sort of pollute your namespace, or your vectors. You basically have too much junk, right? Again, this junk is important, of course, to large language models. They will want to use these, right? Because they provide our, natural flow of language. But for these basic type of words, we might get rid of this V, R, right? So we want to leave these sort of rare words, learning basics, artificial intelligence today, possibly, yes, right? So that would be very common. So these common tasks would be lowercase, remove punctuation, remove stop words. Again, I'm not doing it here, but those would be, if you're building your own bag of words model, probably you want to get rid of these. Now, we have our tokens. Right, so there's some tokenization. You can use an LTK library, there's also a spacing library in Python, very good library. Sadly, it doesn't have its own Latvian support. It has been pretty bad. So that's the problem with Latvian language as far as NLP tasks. The tooling is not so. We have our ALAP at the 929, right? They have some good tooling, some good people actually. PyCans, by the way. Do you have PyCans?
No, we don't.
No, you didn't have him. No? No, so he works actually one of the NLP tasks, right? So if you had access to him, you could ask him all some things. So, but I use some of their tooling at my work, their library, actually, national library. So it's challenging, but you have to build your own tooling, right? In English, if you're doing your work in English, it's easy. There's so much. It's mostly picking up the right, choosing from a sort of, smorgasbord, right, from all the different choices, right? So in Latvian, you have to start with your stuff. Okay. By the way, token. By now you probably know this, but still, because ChatGPT sort of brought this to the forefront, is that token is not necessarily a word, right? It could be something smaller, it could be just a single letter, theoretically, right? But single letters are not really useful for large language models, right? So it's usually a subword, right? So there's something for LLMs, right? They use something called the subword tokenization or byte pair encoding. So basically, idea is this. You have vocabulary, right? You count frequently, and then you start merging. Yeah. So what this does, you have your tokens instead of having 26 letters, right, in English. English 36 tokens technically, right? They build up a 32 or 64K vocabulary, right? So this includes these subwords, right? Many sort of like sections of the word, right? Again, why? It's a compromise. Again, why? Well, because English has about 170,000 words in Oxford Dictionary. I guess Shakespeare has about 50,000 words, I believe, right? But you don't want all the words. So basically, you want the most frequently used sort of like half words, subwords, right? You want them in this vocabulary, but these strange, these rare words, you don't care. You mean they are important, but you basically will be encoding them less, so you can use this, build them up from your tokens, right? So your more complicated words, your rare words.
So it's basically when we introduce this just due to this practical thing.
Yeah, it's a practical reason for it, basically. Yeah, so that's why if you look at your ChatGPT, if you use the API for ChatGPT or any other open API-based access, it's token-based payment, right? So you will see different models like Gemini, Google Gemini, or let's say Grok or DeepSeek, right? They'll have different pricing, and they also have different token sizes, actually, right? So different tokenization algorithms, right? Underneath, most common is BPA, but there's some other alternatives. So again, the token size can vary actually, right? But today we're using very simple, right? Our tokens are basically just words, you know. Okay, so this is something to explore, right? So we'll use three words, but we have three documents, by the way. We call them documents. In this case, they're just sentences. So we are learning basics of artificial intelligence today. We are learning basics of machine learning today, and we are learning basics of deep learning today, right? So three things, right, related. They are actually technically correct because NLP often uses machine learning, right? It's a field of AI, and of course, it might use deep learning. Okay. So what we'll do is we'll tokenize, right? Token split, simple, right? Again, this dot will be present, okay? And then what we'll do is we'll use the vocabulary. So in this case, we'll use vocabulary of 6 words, right? Unknown, right? Unknown is very popular, sort of like a placeholder, right? Means you don't know what it is, right? But we still need to mark it, right? So in this particular case, right, we'll create a bag of words vector, which basically means word, right, how many times it appears. Right? So we have a vocabulary, 7 words, right? 6 words plus a noun, right? Well, the basic idea here is that we're going to count how many times each word or each token appears. I mean, it's so simple, right? But you can do some things here, and we'll see the limitations here. So I will have probably make I should have probably made a function for this. Now, I just copy paste here. So three different bag of words, models, like representations, right? And what will happen? Well, there's some libraries for this. I mean, there's lots of different libraries, but let's see what happens. You'll see that it's kind of funny, right? So our approach, if you are going to try to compare these sentences, right? What happened? We got exactly the same results, right? Why? Well, because we had these stop words. First, we're counting stop words, right? And this happened that if you're going to do some sort of compare these sentences, you say, okay, they're same, exactly the same, right? Because of course, here this model, well, it's by its definition is very limited, right? We had only these 6 words. Our basics learning of today be, right? Well, how could we improve this? Well, or change it, right? Well, we could add some extra words, right? Maybe we want to learn it, right? Right? We could, of course, count all words, right? We could count all words for each sentence, right? That seems very tempting, right? And you could do it, but then there's a challenge. What can you do then? Well, the problem is then you have to come up with a huge vector because potentially your language, 62, maybe you have 62,000 words. Latvian has about actually your thesaurus, you have like 700,000 actually variations, but actually about also about 150,000. So theoretically, you have to have this huge vector of like 100,000 entries, right? Mostly zeros, so extremely sparse, right? And some ones. So yeah, that could sort of work, maybe some twos. In this case, maybe, if it's R, right, you have maybe, lots of count, right? So, but once you have it, right, you can convert this to some vector. So usually, that's why we use this limited vocabulary size, because when you can have, okay, we have fixed size vector, 64,000. Yeah, it's long, but at least you can work with it, right? If you have sort of flexible size, that makes working, well, first of all, some technical challenge, right? Lots of algorithms start to break down if you have, variable size vector, right? And it's literature, most people, most scientists prefer not to deal with it, right? They want fixed size, right? So there's good technical reasons for doing it. So, well, maybe you can come up some, in one of your next year's bachelor's thesis or summer, right? You can see, okay, maybe variable size to show something that works very well. But lots of smart people have been trying it, and I have not seen any real advantage of this. Again, it's mostly technical, why you want fixed size. Right. So, but you also see immediately there is some limits, right? In this case, the limit was that this model generated these three sentences. Let's do one more. Let's do maybe, since I have time, let's do one more. Let's do doc 4, since we have some time. Doc 4. What will it be? Okay, it's doing double now. Are we really learning the basics? So, question mark, right? So, I will do this, so I'll do tokens 4, right? All right, but now, of course, we'll do a vocabulary mistake, but let's do this here, right? So this one, let's create a function, right? Let's create a function. So this is getting, it's called this, why copy paste this code equation? Let's make it. Let's make a function that takes a document and a vocabulary returns bow. Okay, definition, create bow. Hope you can see this, right? It's pretty easy. So we initialize, right? We can do split, right? For tokens, right? And that's it. And else, no, that's it. Of course, we could have used counter. We could have used counter, right? Yes. So that's it. Now, let's do it. So now we don't need these. So we can do this. Bow equals create bow, right? Right, exactly, and exactly. And so I can skip all of these. I can get rid of all this code, right? Right. Okay. Now, on print bow. Let's print the fourth one. And yeah, so zero basics learning, so slightly different, right? V, right? So this of course will be slightly different from the other sentence. Again. So even in this case, right, we change something. So why did we? So first of all, we see the example of why we would probably want to add something. Normalization, right? Let's add something else. Normalization. Normalize equals true, right? If normalize, document is lowercase, right? Lower, that's it. So a flag, and also again, maybe by default, that this will mean, of course, that our R and V, right, the counts now will normalize, right? You don't care about the capitalization, right? So this might be an improvement. It is improvement for most tasks. So now, of course, we see again, we're almost back to the fact square one, right? By normalization, right? Of course, more sentence, right? Our tokens are actually, right? Well, it's more. We know for sure that V exists, R is properly counted. But so now the only difference is there's 3 unknown tokens and 4 unknown tokens. And so we can sort of say, okay, we don't have these, right? Again, in this case, I'm using dictionaries. Of course, you could say you could use these unknown tokens. I could have added them here, right? Again, I should mention this in the comment. We could have added these, but however, that would change the size Yeah. So again, and now of course now we can do some things, right? So it's very simple, right? So order is not considered, right? So by the words cannot distinguish context, right? So next step, again, still a relatively simple step, is introduce what they call n-gram models. So bigram means 2 words, right? Trigram, 3 words, right? They don't say quadrigram, but 4 or 5 n-grams. So some words together. So you have sort of window, right? And use that for something, right? We could count these larger chunks again. So this introduces, right? So this introduces some way of representing some context, right? So again, in a larger sentence, right, you could say he saw her duck, right? But if there is something about the farm, next sentence, it could catch up on that, right? This model, if you feed it a larger document, it could pick up on these, right? So we would feed these we would count these again. Still, most likely it's going to be not counting things for now, right? So again, remember, or I showed you the Markov chain, right? This would be where we could build one, right? Again, a generator, right? So again, in real life, we would use NLTK or Spacegram or some other library. But here we'll see how to do this. So bigrams are extremely simple to make, right? Same thing. Again, especially Python, of course, right? So we're learning basic artificial intelligence. They're awesome, right? So what we do is we create a list of bigrams, right? And again, we could, of course, we could normalize. Okay, yeah, we could also remove punctuation. Yeah, we could remove stopword and so on, right? Okay, but yeah, but let's stick to, so we have now basically you'll have all the bigrams, right? We are learning basics of artificial and so on and so on and so on, right? So now we can count these again. Seems like, okay, so what do we gain by these bigrams? Again, the context of the word use. So whether some words are used together with some other words. And there's other thing we could do, right? I'm going to count them, right? The lady I'm going to count them, right? We are, right? So we count this as a top bigram, right? Everything else is just fine, right? So that's one of the issues with bigrams. It's extremely sparse, right? Bigrams, you can have some common phrases, right? In a large, we have a big document. But the issue is, as we get the trigrams and quadrigrams, and then more higher end, they become unique, right? Just a unique sentence, basically, right? So you don't see it, and of course, there might be some common sayings, some common memes and so on, right? But most like n and n is 10, most of these n's will be unique. So they're rarely used. Only up to about 5 actually provide some useful. So yeah, we could do a character, by the way. We could do a character one, right? But one adjustment we could do is not just count the words that are next to each other, but we look at certain windows. So because usually words have meaning within a certain window, maybe sentence over, maybe a couple words over, right? So instead of counting the words that are right next to it, we count the words which are within, let's say, 5 or 10 distance window size, right? If you talk about again this farm and duck, right? You probably might not see this next to the duck and farm, might not see it, but you might see it maybe 5 words over, right? And again, this will sort of infer the meaning, right? So skipgram. So skipgram means you have a sort of like some freedom, right? So you count the words that are next to, not close to each other, right? I don't know if you're gonna have time, right? So also, high frequency engrams, right? They have stable probability, right? But the low frequencies are, of course, high variance. It's rare words, right? So also known words, right? So what you do is, special anti-symbol, right? Right. Unseen engrams, there's some smoothing techniques, right? So engrams can accurately predict what word is likely to be, right? Right? But again, we saw this, I think you over here with the Markov chain, it does not work very well, right? It just generates some nonsense, right? Unlike GPT, right? So we need some more, how should I say, the patterns, right? They're too simple. They don't capture all the nuance of what else, right? So, because as we're speakers of any language, we may not be native of English, but still we realize there's some patterns, right? So, fulvous kitten, right? Fulvous, I never heard that word actually myself before. This is actually a real world, a real word, right? But it sounds correct, right? Because we don't know, ze, right? Fulvous is actually a real word. We'll check now. I don't think it's fake word, right? It's actually, I think it's in a book. Right. Oh, it is actually reddish. We learned something. Yeah, learned something new today, right? If you can go to Oxford, right? So fulvous.
Fulvous. Fulvous.
Okay. All right. So reddish color, right? Well, we have the meaning, right? It's a color, dull, orange, brownish. All right. Good. Right. So we know it's a kitten, right? It's certainly appropriate for a kitten, right? So, okay. So there's some directions. What can we do next, right? With these type of models, right? There is a WordNet something, a WordNet model, right? Which is basically sort of old approach. We use the hand-picked dictionary, basically, hand-curated, right? Let me show you. Where is it? WordNet, right? WordNet, right? It's a lexical database of English, right? So this is still around, it's still useful, Princeton, right? Prestigious and so on. So we group, the words are grouped by hand, by people, by researchers, by students, by professors, right? And the concepts can be navigated in the browser. Let's check out how that looks like. Word of Princeton. Let me give a link to this. Link. Come on. Come on, give me a link. I'm lazy. Is the AI sleeping today? Or maybe I didn't turn it on. Yeah, so let's turn it on. Okay, link. Link. More, yeah, it's correct. You see, again. So why again? You can see why it works, of course. You can see how ChatGPT works, but because of the context, of course, right? Because around here there's a word, there's enough context to see that there should be a link, right? So, okay, one second. There we go. Okay. Yeah. I get a letter. How many things okay, send it to email then. I'll do that. Okay. All right. We'll be okay. Goodbye. I'll find tonight. Bachelors. Yeah. All right. So we better let's explore this WordNet. Yes. Maybe we can close the door if people are maybe we go back. Yeah, that our colleagues. Let's explore this WordNet a little bit. Right, like this maybe. Apparently there's a coffee machine. Right? Okay, so I think there's a browser-based coordinate. It's still around. Oh no, it's gone. It's gone. Depreciated. Okay,
You can access it through somewhere else. I think I.
it is open. It's right. So you can download. It's open. You can download database. I mean, I've used it before myself, right? So can you see online? It's 2005. So it's again old, right? Again, this is before the. So idea, of course, old versions, right? You can download, browse. People don't need a really old, right? Yeah. So maybe somebody has a closed version. I mean, you can use it. So it's not a test. It's not a test hours. Right? It's not a test hours, right? It groups, right? So it interprets not just word forms, but also sense the word, right? So I would like to show some examples of this, right? Again, because it's still new. Again, it can be still used as part of a larger model, right? This has some meaningful information, some important information. What's happening there? Nothing. Okay. Right. Now, so it's not a thesaurus, it's kind of similar, right? So where is knowledge now? Basically, what we do is next step is part of speech tagging. This can imply add extra knowledge, right? So basically, nouns, pronouns, verbs, adverbs, adjectives, and so on, right? This is typically used, right? We have actually this 45 times in English actually completely, right? So we can assign appropriate word. Each word gets its own tag, right? So maybe I'll show you. Most of you speak guys as a Latvian. I can show you what happens if you do this in Latvian, right? I'll go to ALO, right? NLP, ALO, and NLP, right? It's still around. We have a lot. So let's do some sense, right? Let's do some Latvian sentences. Let's see SMLV, right? SMLV, right? Let's see some sentence, right? Oh yeah, Vemlia, right? Let's see this. Let's see that. So see, right. Right, so we'll see this one here. This is such a pretty simple one. Right, there's only a few sentences, right? But what we'll see here, we'll see a couple of things we do here, right? Right. So actually, this is if you're curious about this, you can reverse engineer the NLP. There's an API underneath, so you can use it also as an API. It's not public. I mean, it's not documented. It's public, right? It's not documented. And so let's do this visualization. Right? So what we do is this. We'll do parsing. We'll do morphological analysis. What's NER? NER stands for named entities. And tokenization is what, of course, what's going to do or heavy lifting. And this is mostly, I'll start there, please. You want to leave this one here. Let's go. Let's go. As you'll see is, right? So, it worked. It's very quick because it's a very small sentence. If you have a book, it's going to take longer. So, what is GPE? Geopolitical entity, right? You see this, right? So, 24th of March, it's time. Again, right? Again, how is this done? This is rules-based. This is 90s, 2000s technology, meaning there's the researchers in a Latvian universities, they actually, basically, their students basically work through a bunch of documents and how to input this, basically. Right? Of course, there's some fancy rules there, right? But it's not a neural network. There's some parts here, but it's not trained. It's actually hand curated. There are rules there, basically, right? But it works really well, actually, right? So England, right? So Wembley, right? It's an event. Well, actually, it failed here. It says that it's an event. It's actually a place, right? It thinks it's an event, right? So, right. So these are named entities. Now let's look at the JSON here, right? So we'll do is, right? Looks like this, right? Sentences. So it first of all tells you the named entities, right? I'll skip those. You can, of course, do some sort of JSON. We have Notepad, Notepad was possible. We have here. Actually, I could add it here. Let's add this. I can copy it. I actually copy it here. I'll show you this in a moment. You see? whole bunch of stuff. Like 3 sentences, I got a whole bunch of JSON. Right? So I'll go back to our here, right? Example, data. I'll do some data. Right. Go. Let's see the file. Latvia, England. JSON, right? Latvia first, of course. Right? So Control V, right? So yeah, it's nice. It's proper JSON as it should be, right? So also there's a plain, there's the actual sentence. Look at this for each token, including punctuation, you get a whole bunch of stuff. You get features, right? Like this. You tell me what kind of word it is, and also you get interestingly, you get dependencies. Which word depends on which word. In Latvian, it's important, right? So sectoral, right? So it tries to give you, okay, what kind of word? It gives you all morphological features, right? And also it gives you something called lemma, right? Lemma is like the kind of like root, not root. It's kind of similar. Basically, the main the main word, but its words, the core, what do I say that? The main name for this particular entity, right? So funds would be the sort of like the standard, like the core, I would say I wouldn't say most frequent way, but I guess you took Latvian in some of you took Latvian in our high school. How your Latvian teacher would say, right, or English teacher would say, right. So there's a particular meaning, particular kind of similar to root, but not really root because it could have a different, declination in some words. So yeah, so this is what we have. That's our next step. So now we have really rich model. Each token, yeah, used, yeah. So in this case, former lemma is same, because right. So lead is also same. Latvia, right? You see.
I once upon a time, well, it was a long time ago, tried to make it on my own, like that. I get
something.
I get the lemma.
Yeah.
Random word.
Yeah, so it is, by the way, there's a guy who did his PhD thesis on this in Latvia, and he only got as far, he did the stemmer, and he only did like couple part of speech. He didn't do all of it, so he got a PhD for that, right? I'm saying, yeah, it's a hard work, but we still, there's at least which means you get like 2 more PhDs, I guess, right? If you want, right? So, yeah, so this is a hard problem to solve, right? Now, we'll see, of course, there's a ways of getting now using LLMs to do that, right? You don't need only rules based. Okay, let's leave it Latvia, England. Latvia, England, from NLP 5. Example, right? Yes. Okay. Guess the rest of okay, this thing here. I have to do this git pull, I'll do this. Yeah, I have to do this thing. Git pull config swarm, I think, right? Yeah. Hello. Let's see this work. Yeah, so now we can do it. Okay, so they do. Oh man, no fast forward. I think this. Yeah. This shows how lazy I am. Yeah. There should be a conflict. Yeah, no, should go.
Yeah, they do.
Okay. Yeah, now we will. Okay. All right. So now part of this, so part speech tagging, right? So it is a pretty complex issue, right? Again, so we can use the rules. I mean, again, same problem with duck. He saw her duck. Is duck a verb or is it a noun, right? On this issue, this Latvian version, it is not 100% accurate. It's about, let's say, 97, 98% accurate, right? Let's think of some sentence which in Latvian maybe, which is kind of ambiguous. Nothing too obscene. Nothing too obscene. No. I will of course ask ChatGPT to come up with a ambiguous sentence that work, right?
But ambiguous in what sense?
Meaning, the meaning is not immediately obvious from just single sentence, right? So he saw her duck. We don't know what the sentence is really. We know here we have a couple options. We have maybe probabilities, but we don't know. So something like that, like a couple word sentence in Latvian, which is ambiguous. Let me see if I can check it out here. I'll see what ChatGPT says. Provide example of ambiguous sentence in Latvian. Let's see what it's again. It's still pretty bad, right? I have to check some other Latvian models are pretty still bad. And it looks like the new law, which was just passed a couple of weeks ago, right, or last week, right? Okay, I like the examples I give you. Es redzēju vīrieti ar teleskopu. Yes. Yeah. Okay. All right. Let's go for it. Es redzēju vīrieti ar teleskopu. So the question, of course, is, so this is kind of telescope. Yeah. Right. Okay. So we'll see what it provides. Right. Yeah, so the ambiguity for those who don't speak Latvian too much, of course, is basically because who saw? Did you see the man with the telescope, or were you using telescope to watch that man, basically, right?
All righty.
I know it's stupid. Okay, but yeah. Yeah. So what does NLP thinks, right? The AI thinks. Okay, S of course, there's no question, right? It's redzēju, right? So in fact here, for parts of speech tagging, the only thing that will be different is that which word depends on which tone. Comma, of course, same. So telescope, right? So it thinks actually looks like telescope is man's. So this looks like that it thinks the man has a telescope, not you. Right. So that's what it looks like, right? Dependencies here, right? So, yeah, that's the case. So it's probably because why we can probably use this, this closest, probably use, to the closest version, right, where it should be, right? So it brings the dependency graph actually, right? Kind of cool, right? So what is any other ones? Yeah, I want some more examples. They will be probably similarly stupid. And I broke ChatGPT. Okay, no.
Should I pen it? Yeah.
Okay. This is like not a good example. Say, viņi runāja skolotāji par skolēnu. It's just one interpretation. No, it's wrong. It's a wrong example. You see. Okay, yeah, no, so bērni zīmē kaķus jumtu, the same story, right? Yes. So which meaning? Are the kids drawing the cat on the roof, or were they on the roof when they were drawing the cat? Right? Kind of works, I guess, but not really. I would say probably, of course, or immediate interpretation would be that the cat is on the roof and the kids are drawing it, right? That seems more normal, right? So not very good examples. Yeah. Okay, the last example will finish this, right? So, zēns sita vīrieti ar nūju. A boy was hitting a man with a stick. Right, a great example. I guess, was the boy beating up the man who had a stick, or was the boy using a stick to beat up the man? Right? I guess we can try this one out, right? Let's try this out. I don't know. All right. I don't know which one. It seems unlikely in either case, right? Maybe he's attacking his hockey coach or something. I don't know. Right? All right. So what does it say? Okay, 1, 2. Right. Look at the index parent. Right. So that, of course, right. Six, right. So of course, those are dependent. Periods, of course. Yeah, of course. 5. No. 2. So it looks like that in this case, it seems to think that actually the boy has the stick in this case. Yeah. Otherwise, of course, makes sense if you think about, of course, why would the boy attack somebody without, it's like if the man has a stick, right? You have to be a real, I don't know, karate expert or something, I don't know, right? It's possible, I guess, right? So, yeah, but we digress, right? So, yeah, so you want to, of course, so you can, so by the words, technically unigram. Then we have bigram, trigram, program models. We can add these skip words, right? You can experiment with tokenization, right? And then, of course, what we'll do is actually, right, we get into, when the book came out, we only had GPT-2. We have GPT-4 now. This came out 4 years ago, which is ancient, right? The book is ancient, 4 years, and this is the best book, right? I mean, so GPT-2 only had come out, right? So basically, it mentions that sometimes like I don't develop that argument, right? Well, not again. I would like to see the new edition. Probably the new edition come out next year, probably. So the idea, of course, is that the context is these large language models is a much larger window of the context. Right. So it's able beyond simple binary models. Now, right? Yeah. So natural language models. We don't talk about the formal grammars. We spoke about that in our language and programming language class, right? And it's slightly when it comes to human language, the grammars again. There's ambiguity. There's no 100% rules, right? That's why these probabilistic large language models work so well, because there's always probability. Not everything is set in stone. So parsing, right? Again, we need parse, right? Of course. Grammar. Okay, so this example we will say which word is which, right? So return cat. Then deterministic cat is known. Sat is verb, on, right? On, right? Generate parse. That's how roughly the NLP 5 works, actually. Roughly, but of course, much more complex. What else? On the grammars, we will, of course, create more grammars. Semantic meaning, right? So long distance dependencies, again, sometimes. What's the big challenge in previous these simple models was if you're referring to something and you are like referring to something 3 sentences later, like John, right, or Alice, let's say Alice, right? When you talk about her like 6 sentences later, right? Is this Alice? It's obviously not Bob, right? But is it Alice or maybe it's Carol, right? Which one are you referring to? And again, as with our language models, they can pick up on this, right? This context window is getting larger and larger. We talk about context windows, right? How much information stays relevant? Again, that might be an issue. So, let's see if we can get to tasks. So, typical tasks today, what we do with NLP. Speech recognition, right? Spoken language in the text. What do we use these days? Whisper, probably, right? Right? Anybody use Whisper? Okay, good. Okay, sometimes, from what I heard, VLC player actually will include it by default. You can get subtitles on the run on basically live subtitles on the shows. You have never seen it, even if it doesn't have any subtitles, right? It works pretty decently for Latvian, by the way, right? I'll give you a link to this. Right? Whisper, right? Amazon Whisper, of course, right? Come on. Yeah, Google Voice, Apple Siri, and so on. So, right. So, there's a, you can play around with it. What was OpenAI? I forget now. Who made this? I believe it's Amazon, right? Or OpenAI.
I think OpenAI.
Let's double check.
Yeah, that's OpenAI.
Yeah, OpenAI Whisper? Yep. See? Yeah. Yeah. Okay, it is Whisper. So.
It's open source.
Yeah, it's open source. I run it myself on my own computer. You can, of course, if you want, you can pay it. I mean, sure. There are plenty of companies who take your money, right? But you're gonna do all of it, right? So, yeah. So, there's some system service. You see, this is what you want, but this is like 3 years ago, right? So what happened? What's underneath here, right? So the gray, they're open source. It's neural net. It's based on neural net, basically. So there was actually they don't say how deep it was, like how many layers of the network there were actually, right? So basically, what happened here, right?
This is the Micro Machine Man presenting the most midget miniature motorcade of micro machines. Each one has dramatic details, terrific twists, precision page jobs, plus incredible micro machine pocket playsets. There's a police station, fire station, restaurant, service station, and more. Perfect pocket portables to take any place. And there are many miniature playsets to play with, and each one comes with its own special edition micro machine vehicle and fun, fantastic features that miraculously move. Raise the ball at the airport marina, man the gun turret at the army base, clean your car at the car wash, raise the toll bridge. And these playsets fit together to form a micro machine world. Micro machine pocket playsets, so tremendously tiny, so perfectly precise, so dazzlingly detailed, you'll want to pocket them all. Micro machines and micro machine pocket playsets sold separately from Galoob. The smaller they are, the better they are.
You can see how it's made, right? So what's happening here, of course, you have the spectrogram of the speech, right? You encode it into numbers, right? And you have a decoder, right? To try to predict the next token, of course, right? So reveal transcript. Where's the transcript? Oh, here we go. Machine man, the most important. Oh yeah. Yeah. But yeah, so in practice it works pretty well, right? Again, it's not Amazon. I think they just show you. Basically, Amazon is of course famous for that. You leaving? Okay, we'll finish in a moment. Right. So, Amazon is of course famous for taking open source models on offering them, right? So I would not be surprised if it's basically running Whisper. Amazon Whisper is running Whisper, basically, OpenAI Whisper. So OpenAI Whisper is an open one. Yeah. So GPT. Well, it does run GPT, but it's not quite so. Yeah. The speech text, speech. Okay. Now, so you go the other way, text to speech. Again, I remember how it was in the 1980s when you were a kid. They had this speak and spell these computers. You type some letters and you have generate some speech. It's extremely robotic. Of course, these days you can clone anybody's voice, right? Easy. Has anyone yet cloned their own voice? I'm thinking about it, right?
Or professor in another course showed how he has done it.
Yeah. So how much time? Do you remember how much training he used? I mean, there's one very you don't need much actually. You don't need much.
The service he used.
Yeah. It's very. You don't need much. I mean, the results you get pretty good results even for very little, right? So some services. You can even train your own. Oh. All right. to name entity recognition, right? So then we saw this, right? So you want, all the time, you want to identify specific things. In NLP, whether Latvia is geopolitical entity, whether it's a team, maybe it's a stadium, maybe it's a bread, right? Or maybe it's something else, right? So, sentiment analysis, huge, right? It's a classical classification task. Say whether a movie review is good or bad or so, right? Everywhere, right? This determining whether something is something, right? Summarization, right? Machine translation, which goes together, right? Language generation, right? Information retrieval, right? This is sort of older technology, but still important, right? If you're building a search engine, how would you build a search engine? Well, probably keywords, right? You know, database, right? How do you do it quickly, right? Also indexing, start thinking, how would this search report? How do you do search for documents, right? As Google did about 27, 28 years ago, right? Initially, right? So how do you extract? How do you make it quick to extract, right? How does this quick search? How do you do it? How does Elasticsearch work, right? The technology, right? So of course, question answering, right? And challenge in advance. Of course, so there's a lot of challenges that we see. Of course, that these large models can sort of do pretty much all these tasks, right? So, right, so, yeah, so these are all the backgrounds. I will show you the new paper on, I mentioned here, there's more to it, however. Papers, yeah, so this one here. So this is extremely important. Attention, right? So this paper of 2017 introduced this transformer model. This is like the huge, all these papers are important actually, right? Board vehicles kind of cool for embeddings. This actually I use myself. Still, it's fast, but this is the paper, right? To read, right? With all these guys, they all have Anthropic, they use Google also, right? And they all have their own, they're all own unicorn billion dollar companies, basically, right? So, what I said is they only need one model, this large language model, right? Specific way of encoding data, basically, right? How to work for everything, basically. Basically, you can sort of, by providing your prompts, you can accomplish many tasks which you used to need specific tooling, specific algorithms. You sort of like do everything with just feeding enough data, right? So that's the idea. Of course, now I think we reached sort of like a plateau with this technology, right? Because we have OpenAI 4.5, not so great, right? It's all getting pretty good, but not fantastic. I mean, singularity is not happening, I guess, right? So it's good news for us, right? There's still place for us, right? No paperclip problem, right? Hopefully. Right? So, we have time, not today, but we'll look at also how to build your own GPT at home, right? If you want. Of course, you won't be able to build a really full model, right? It's actually quite simple. The only problem is that, yeah, it's simple, but the problem is you don't have the data, you don't have the computing power. That's all it is, really, right? And then you have to play, and then you need, of course, so you need to prepare, you need to, get a whole bunch of books and documents, right? You feed into the model, right? So that's the easy part, get a bunch of books. I'm sure you know how to get the books, right? So, in fact, you know what Facebook did, right? To build Llama, right? Where they got the books, right? We all know, right? So it's hilarious, actually, right? But the problem is then you have to play around with the weights, right? You have these parameters in your model, right? On each run, to get a good model, it maybe takes a couple months on a really expensive hardware, right? Then the experimentation, there's not much room for experimentation, basically, right? You build it, does it work? You just blew $5 million or $10 million, nothing, it doesn't work, right? So that's the issue. I think, so that's what's happening with OpenAI. I think they sort of blew it in the 4.5, right? They spent probably a couple billion in that one, right? It didn't really, it's good. It has good vibes, right? But it's not fantastic. Yeah, as I said, it's a vibe model, right? So yeah. So we can talk about this. We'll have time on how the GPT actually runs underneath the actual layout. This paper is crucial for this. Now, let's see what else we have for we are finishing. Actually, we have only 3 more lectures this week, right?
Mm-hmm.
Yeah. So let's double check. We have next on Thursday, so 31st, and then on 3rd of April, right? So on 7th, we'll have consultations, but no more lectures, right? Is that correct? Yeah? Okay. So let's see what else we have not yet covered. I mean, I would like, of course, to do more work on this learning, right? Yes, okay. All right, guys, let's finish today. That's it. All right. Maybe any questions for those who are not leaving yet? Okay. I'll talk a little bit what we have as far as the book materials, right? So deep learning NLP, right? This one is a book we built on GPT, right? GPT at home, right? Then we talk about the next week is computer vision and robotics. So ethics you'll have to learn on yourself, right? Hopefully, right? Do not be evil. Do not be evil, right? Okay.
Yeah, that's the whole lecture.
Yeah.
Okay.
Good message.
Yeah, that's very crucial.